Assalamu alaikum students. I hope you are all fine. Today is your 10th online class of class 9 Federal Board. Subject is chemistry. Today we will discuss isotopes and its uses. Learning object of this lecture. At the end of this lecture you will be able to define isotopes, similarities of isotopes, dissimilarities of isotopes and uses of isotopes. First we discuss isotopes. Isotopes is a Greek word. Iso means same and top means place. So isotopes are atoms of the same element which contain the same number of proton but different number of neutrons. Or we can say that isotopes have the same chemical properties but slightly different physical properties, because chemical properties of an element depend upon the number of protons and electrons. Neutrons do not take part in ordinary chemical reaction. For example, here is an isotopes of oxygen. You can see here all oxygen atoms have same atomic number, that is 8. Or we can say that number of protons in all atoms are same, but number of neutrons in all atoms are different. Oxygen 16 have 8 neutrons, oxygen 17 have 9 neutrons and oxygen 18 have 10 neutrons. Isotopes of hydrogen. Hydrogen has 3 isotopes: protium, deuterium and tritium. Almost all the hydrogen, that is protium, hydrogen 1, its symbol is 1H1, its atomic number is 1 and mass number is also 1. It has only 1 proton, 1 electron and 0 neutron. Hydrogen 2, that is deuterium, it is also called heavy hydrogen. Its symbol is 1H2, its atomic number is 1 and mass number is 2. It has 1 proton, 1 electron and 1 neutron. Tritium symbol is 1H3, its atomic number is 1 and mass number is 3. It has 1 proton, 1 electron and 2 neutrons. Water that contain hydrogen 2, deuterium in place of protium, hydrogen 1, is called heavy hydrogen. Naturally occurring hydrogen contain 99.99% protium, 0.0156% deuterium. Tritium is radioactive and is rare. Now isotopes of carbon. Carbon has 3 isotopes: carbon 12, carbon 13 and carbon 14. Almost all the carbon is carbon 12. Its symbol is C612. It has 6 protons and 6 neutrons. Carbon 13 symbol is C613. It has 6 protons and 7 neutrons. Carbon 14 symbol is C614. It has 6 protons and 8 neutrons. Different form of carbon are black or grayish black solid except diamond. They are odorless and tasteless. They have high melting and boiling point and are also insoluble in water. Natural abundance of isotopes of carbon is: carbon 12 is 98.9%, carbon 13 is 1.1% and carbon 14 is less than 0.0001%. Now isotopes of chlorine. Chlorine has 2 isotopes, chlorine 35 and chlorine 37. Chlorine 35 symbol is chlorine 1735. It has 17 proton and 18 neutrons. Chlorine 37 symbol is chlorine 1737. It has 17 proton and 20 neutrons. Natural abundance of chlorine 35 is 75% and chlorine 37 is 25%. Now isotopes of uranium. Uranium has 3 isotopes with mass number 234, 235 and 238. Uranium 235 is used in nuclear reactor and atomic bombs. Uranium 238 isotopes lacks the properties necessary for these applications. Uranium 234 is rare. Natural abundance of uranium isotopes are: uranium 234 is 0.006%, uranium 235 is 0.71%, and uranium 238 is 99%. Now, we discuss the similarities and dissimilarities of the isotopes of an element. The similarities between the isotopes of an element are: they have same number of protons, they have same number of electrons, they have same chemical properties, and they have same atomic numbers. The dissimilarities between the isotopes of an element are: they have different number of neutrons, different mass number, different physical properties, and different natural abundance. Now we discuss the uses of isotopes. Stable and radioactive isotopes have many applications in science and medicines. Some of these are as follows. Iodine 123 is used to image the brain. For this purpose, a radioisotope is taken in by a patient. The radiation emitted enables organ to be easily imaged by imaging equipments. Disorder can then be detected and treated. Iodine 131 will be used as a tracer in diagnosing thyroid problem. Iodine 131 will be used. 1/4 of the total amount of iodine in the body can be stored in the thyroid gland. Amount of iodine entering the gland can be seen by detecting the radioactive emitted from the radioactive iodine. Sodium 24 is injected into the blood stream to detect the position of blood clots or thrombosis in the blood vessels. Brain tumor can be detected and treated by using phosphorus 32. Radioisotope cobalt-60 is used to sterilize medical equipment. Cobalt-60 is also used to irradiate cancer cells in the hope of killing or shrinking the tumor. In archaeology, carbon-14 is used. Carbon-14 is a radioisotope with a half-life of 5730 years and decays by emitting beta particles. Living animals and plants have a known proportion of carbon-14 in their tissues, which remain constant and decreases when they die. The amount of carbon-14 left in a decayed plant or animal can be used to tell its age. I hope all of you understand isotopes and its uses. Now I am going to give you some home assignment that is related to this topic. Do review question number 2, part 6. Review question number 10, 11, 12, 13 and 14. So that's all for today. Thank you.